Hey guys, today's lesson is on section 3.3, rate of change and slope. Slope is the ratio of the change of the y coordinates to the corresponding change of the x coordinates. What it is it's the line on a coordinate plane's rate of change, or how quickly a line is increasing or decreasing. That is what the slope represents. In order to calculate slope, we have our slope formula. M stands for slope, and the way that we're going to calculate it is dividing the difference of the y values divided by the difference of the x values, or the second y coordinate minus the first y coordinate divided by the second y coordinate minus the first y coordinate. Down below, we see some examples where we're going to find the slope of the line that passes through the following ordered pairs. So what we're going to do is put the coordinates in the slope formula and find the value of the slope. That will tell us whether the line is increasing or decreasing. So for problem number 1, as you can see at the top of the ordered pairs, we do have the x1, y1, x2, and y2 already notated for us. Since the first point, negative 1, 2, is the first point listed, that would be our x1 and y1 values. And the second point, 3, 4, since it's the second point listed, that would be our x2 and our y2. So when we put them into the formula, m equals y2 minus y1 over x2 minus x1, in this case, we'll get 4 minus 2 divided by 3 minus negative 1. From here, we're going to simplify. 4 minus 2 is 2, and 3 minus negative 1, we're going to add to get 4. And the last step would be to simplify our answer if we could. The fraction 2/4 can reduce to 1/2. Our slope for the line that passes through those 2 points is 1/2. What does this tell us about the line? Since the slope is positive, this line is increasing. There is actually 4 different types of slopes that we'll see, in which will tell us something about the line. In this case, again, since our slope was positive, our line will be increasing. Let's take a look at problem number 2, in which we have 2 different ordered pairs. Again, we're going to put them in the slope formula, y2 minus y1 over x2 minus x1. In this case, we'll have 1 minus negative 2 divided by negative 4 minus negative 1. We're going to go ahead and simplify that. 1 minus negative 2 is going to be positive 3, and negative 4 minus negative 1 will be negative 3. Again, just like problem number 1, we're going to simplify that fraction if we could, and in this case, 3 divided by negative 3 will be negative 1. The slope of the line that passes through those 2 points is negative 1. Unlike the first problem, the slope was positive, so the line was increasing. In this case, the slope here is negative, so our line is decreasing. The next 2 problems, we're going to do the same work. However, we're going to get 2 different types of slope. So the first problem, slope was positive, so the line is increasing. The second problem, our slope was a negative number, so we know our line is decreasing. Let's take a look at problem number 3. We're going to plug into our formula, m equals y2 minus y1 divided by x2 minus x1. When we substitute our values in this case, we're going to have 2 minus 2 divided by negative 1 minus 1. When we simplify, 2 minus 2 is 0, and negative 1 minus 1 is negative 2. We can simplify this fraction, 0 divided by negative 2, which our value is going to be 0. 0 divided by any number is 0. In this case, the value of our slope is 0. Therefore, this tells us that the line is going to be horizontal. A line with a slope of the value 0 is a horizontal line. That is a line that is parallel to the x-axis. For example, the line could look like this, horizontal. For 4, yet again, we're going to see a different type of slope. So far we have a positive slope in problem number 1. The line is increasing. A negative slope in problem number 2. The line is decreasing. In number 3, the value of the slope is 0, so that would represent a horizontal line. And in number 4, we're going to plug into our slope formula, y2 minus y1 divided by x2 minus x1. Substituting our values in would be 3 minus negative 2 divided by 1 minus 1. Simplifying the top, 3 minus negative 2 is 5. 1 minus 1 is 0. Just like the first couple, we can simplify this answer, 5 divided by 0. If we were to put this in our calculator, your calculator will either say error or UNDF, that represents undefined. You cannot divide any number divided by 0. Therefore, the value of the slope is undefined. Our answer isn't 5 divided by 0. The answer for the slope for this problem is an undefined slope. A quick way to remember the difference between 0 and undefined is in number 3. The 0 was in the numerator or at the top of the fraction. Therefore, the answer is 0. In number 4, the 0 was in the bottom or underneath the fraction in the denominator. If the 0 is underneath, our answer is undefined. What kind of line will this show us? That will be a vertical line. Vertical lines have an undefined slope. How would a vertical line look on the coordinate plane? A quick sketch, a vertical line goes up and down, opposite than a horizontal line. An example of a vertical line would be this here, parallel to the y-axis. Our next page of our notes here is called rate of change. And what you need to know about rate of change is it's the rate of something increasing or decreasing. Instead of slope, which is the rate of a line increasing or decreasing, the rate of change, we're still going to use the slope formula, but it's called the rate of change because now the line represents a data. We're representing something that is increasing or decreasing. A rate of, in, for example, question 1, we're going to find the rate of temperature changing. In number 2, we'll find the rate of a pool being filled or water changing. Okay, so we're still going to use the slope formula when you see the phrase rate of change. However, we're going to be using different data. In number 1, it says the table shows the temperature of a solution after it's been removed from heat. Find the rate of change in the temperature for the solution, and they give us a table on the right. Since we want to find the rate of the temperature changing for the entire time they took the data, what we're going to do is always use the first ordered pair and the last ordered pair. Again, rate of change will be using the slope formula, so we will have 2 ordered pairs in order to calculate. The first ordered pair is 0, 143.6, and the second ordered pair would be 12, 118.4. Let's go ahead and notate what our x1 and y1 will be and our x2 and y2. Since my first ordered pair is 0, 143.6, this will be my x1, y1. And the second pair I listed will be my x2, y2. When we plug this into our slope formula, y2 minus y1 divided by x2 minus x1, we'll get 118.4 minus 143.6 divided by 12 minus 0. In our calculator, when we subtract and divide by 12, the answer is going to be negative 2.1. What is this answer telling us about the rate of the temperature changing? Well, since it's negative, we know the temperature is decreasing. How much is the temperature decreasing by? It is decreasing by 2.1 degrees Celsius. So our answer will be the temperature of the solution is decreasing by 2.1 degrees Celsius per minute. In number 2, they give us a graph instead of a table, and the description is that the graph shows the number of gallons of water in a swimming pool as it's being filled. At what rate is the pool being filled? Well, on the graph, they actually give us 2 ordered pairs that they'd like us to use for our data. So I'm going to go over and just copy them down. The first ordered pair is 3,108. And the second ordered pair is 7,252. Again, let's just note what our x1 and y1 and x2 and y2 will be. Since this is my first ordered pair, I'll label x1, y1, and my second ordered pair will be my x2, y2. When we put this information into our slope formula, y2 minus 1 divided by x2 minus x1, we'll get 252 minus 108 divided by 7 minus 3. After you subtract and divide in your calculator, we'll get the answer of 36. What does this represent for our word problem? The pool is being filled 36 gallons per minute. So in our notebooks, as our answer, we could write the pool is being filled 36 gallons per minute. Our last word problem, number 3, gives us data in the paragraph that we see. It says, for the gym, Hector and his class walked around the track. 5 minutes into class, they walked 100 yards, and 30 minutes into class, they walked 850 yards. What is the rate that Hector and his class walked around the track? So again, we need 2 ordered pairs to find the rate of change. In this case, we have to make the ordered pairs on our own. Our first ordered pair is going to be using the first sentence that says 5 minutes into class, they walked 100 yards. So our first ordered pair is going to be 5, 100. And my second ordered pair will be using the next sentence, 30 minutes into class, they walked 850 yards. So the next ordered pair will be 30, 850. Now that I have my 2 ordered pairs, we could go ahead and put this in our slope formula, y2 minus y1 over x2 minus x1. And like the above problems, this will be my x1, y1 since it's my first ordered pair, and my second ordered pair will be my x2, y2. When I plug that in, we'll have 850 minus 100 divided by 30 minus 5. That's going to give us 750 divided by 25. And when we divide that, we're going to get the answer of 30. What does this represent about Hector and his gym class? We could say the class walked 30 yards per minute. As you can see, slope and rate of change, we are using the same formula. However, rate of change is just describing some data changing. Please let me know if you guys have